Quickly, welcome to Exquisite Tutorials, and today we're going to take in chemistry and we're going to be taking matter. This video is for post-UTME students, JAMB students, and as well university students, but I'm doing this mostly for the sake of post-UTME students. Now, in this year's post-UTME, we're going to cover all topics that you are going to need in your chemistry class for the post-UTME. So we need you to follow us sincerely and you're going to get an A. You're going to get an excellent score in your post-UTME. Now we're going to be talking about matter. Now, we understand matter. I'm going to be teaching you this practically for you to understand. We made us to understand that matter is anything that has mass and occupies space. Now, mark these two words, mass and space. So whenever you are talking about matter, you are talking about mass and space. For those who do not know the difference between mass and weight, mass is your normal mass in kilogram, while weight is mass. Weight is equals to mass times acceleration due to gravity. This is weight. So when we are talking about matter, we are talking about mass and space, because when you say weight, there are some substances who do have mass that you can talk about their mass without talking about their weight. Okay, now let's proceed. Which is to say, for example, this is my marker. This marker has a mass because this matter can be measured in kilogram. It's heavy. Holding it in my hands alone is heavy. Now, and this matter occupies a space. If I put this marker here now, you can no longer see this board. Please follow me. Or if I put this duster here, you can no longer see this board, the inside of this board, but we are only seeing the duster, which is to let you know that this duster occupies a space. It's occupying the space of the board, which is to tell you know that anything that you can hold or anything at all that you can see that is visible has mass and occupies a space, because if you cannot see it, that means there's no space that is occupied. Now, matters are built or are categorized into two categories. We have pure and impure. Pure and impure. Okay, I'm going to tell you about pure and impure samples. Now, when we talk about a pure sample, what do we mean to say that a sample is pure? Please follow up with my classes and you will get all the gist. What do we mean to say when a sample is pure? Now let's take first of all characteristics of a pure samples. How to identify a pure sample. Characteristics of pure samples. Now, when we talk about a pure sample, one of the categories that a pure sample has a definite shape. The shape doesn't change. Now, let's say, for example, I'm not saying this marker is pure, but this marker has the characteristics of a pure sample. Now, this is the shape of this marker. This shape is definite. You cannot come today and this marker is bent. Or when you leave this marker alone, you cannot come and you discover that this marker has changed shape. So this is one of the characteristics of a pure sample. Definite shape. 2. The second characteristics of a pure sample is that a pure sample cannot be changed easily through a physical means. It cannot be changed easily through a physical means. Now, what we talk about a physical means. Means that, okay, let's say for example, a pure water cannot be changed easily through a physical means unless you add a chemical substance to it. When you put a water into fridge, it still remains water. When you boil it, it's still water. So we can have boiled water and cold water. That does not mean that it has changed through a physical means. Now, let's talk about another example of pure substance. One you should be very be familiar with is composition is definite. Now, first of all, talk about definite shape. Now, composition. When we say composition in chemistry, what does it mean? Composition means the constituents of the substance. What makes up the substance? Now, let's say, for example, let's say water, H2O. This is the composition of water. Water is made up of two atoms of hydrogen with one atom of oxygen. Now, let's say, for example, this is water. The composition of water, of a pure water, is constant. It cannot change to two atoms of oxygen and one atom of hydrogen. Okay, let's say this is water. This is not water. This is not water. So the composition remains the same. That is one thing to know a pure substance. Now, one more thing that you should be familiar with. Let's say, for example, a pure liquid and a pure solid. First of all, let's talk about a pure solid. Number 3, pure solid. A pure solid has a sharp melting point. Melting point. Now, when we talk about a pure solid having a sharp melting point, let's say, for example, if water has a melting point of 0 degrees Celsius, it means that once you get to this temperature, irrespective of the quantity of the water, what the water is going to melt. Irrespective of the quantity, irrespective of what is involved, once it gets to this temperature, your water is going to melt. You are getting the gist. Now, let's say, for example, this thing has, in a solid form, it has a melting point of, let's say, minus 20 degrees Celsius. It means that when you place this thing on heat, once it gets to 20 degrees Celsius, it's going to melt. And also, solids, pure solid has a narrow melting range. Now, what do we mean by a narrow melting range? When we talk about a narrow melting range, we are talking about substances. You know, sometimes impurities may be present. The melting range should not be more than, let's say, if it has a melting range of minus 100 to minus 102. This is a short melting range. But once the melting range is between minus 100 to minus 118, it's already a very long melting range. So now melting range means that no matter what's happened or the quantity within this range is going to melt. So if the melting range is short, it means it's pure. If it's long like this, it means it's impure. Now, the boiling point of a solid substance, just like we talk about the melting point of a solid substance, the boiling point of a liquid pure substance is sharp. Everything sharp. Melting point. Okay, now let's say, for example, water has a melting boiling. We talked about melting before. boiling point, Now let's say, for example, water has a boiling point of 100 degrees Celsius, just like we explained. Once it gets to 100 degrees Celsius, your water is going to boil. Your water is going to boil and has a narrow melting range. Okay, let's say 100 to 101. This is a narrow melting range. So with this, these are the characteristics of a pure substance. Now, talking about impure substance, we can actually from pure substance understand impure substance. Now, if you know the characteristics of pure substance, you should be able to use it to understand the characteristics of impure substance. If pure substance have definite shape, it means impure substance will not have a definite shape. If pure substance has a definite composition, impure substance will definitely not have a definite composition. If pure substance has a sharp melting point, impurely solid will definitely not have. So once you know the characteristics of a pure substance, you should be able to understand the characteristics of an impure substance. Now, let's proceed. Let me ask you a question. If we have a substance with a melting range of 102 to 108, is it a pure or an impure substance? You can pause the video, answer. Definitely an impure substance. Definitely an impure substance, because it made us to understand that pure substances have a narrow melting range. Okay, now let's talk about the states of matter and the changes. Okay, now let's look into the states of matter. Now, looking into the state of matter, we have the solid, we have the liquid, and gas. We have the solid, the liquid, and the gas. Now, what we'll talk about the solid. Solid substances are those substances that have a definite shape. This is solid. The shape of this thing cannot change. Definite shape. Now, when we talk about substances or matter, there's what we call intermolecular forces. Intermolecular forces are those forces that bind substances together. That the forces of attraction that binds substances together. Now, for a solid like this, the intermolecular force is high. Okay? Solid. Definite shape. 1. Definite shape. 2. Chemistry. Strong intermolecular force. Strong intermolecular force. Now, one thing about solid is that they do not have high kinetic energy. You know, kinetic energy is the ability of a substance to be in motion. So solid do not have high kinetic energy because their intermolecular forces are high. Let's go to liquid. Liquid are substances which has a lesser intermolecular forces than solid. Now, liquid are substances that can flow, for example, your water. Okay, let's say, for example, your water. Okay, let me use this thing to explain the states of water, the ice, the water, and the vapor. Now, you remember that the ice has a definite shape, ice of a water. The water are together to form one. But once the intermolecular forces gets reduced, you see that they start to form liquid. Now, you can pour your water into a container and to take the shape of the container. But normal, your ice, you cannot put it into a container and take the shape of the container. The ice has its own shape. But when it turns to the liquid water, it takes the shape of your container. Now, once it turns to vapor, vapor do not take the shape of anything. The vapor goes into the atmosphere because they do not have any intermolecular forces holding them together, but they have high or strong kinetic forces which takes them up run. Okay, I think that should be all for state of matter. Now, we are going to treat change in state. We're going to treat change in state. Now, the change in state is the changes which water or the substances or matter or that goes to change from solid to gas, from gas to liquid, liquid, continuously, continuously. Okay, let's take solid to liquid. Now, when a substance moves from the place of solid to liquid, it is called melting. That is why we call it melting point of a solid. When substance moves from solid to liquid, it's called melting point of a solid. Now, how about liquid to solid? Liquid to solid is freezing. How about liquid to gas? Liquid to gas is vaporization. Vaporization. That's vaporization, or you can call it boiling. Now we have gas back to liquid. Gas to liquid. It is called condensation. Then we have solid. Solid straight to gas. It is called sublimation. Sublimation. Now, take note of sublimation. Sublimation is a common question in chemistry. And when you ask about substances that can sublime, iodine is one of them. Now, sublimation is the process whereby a substance goes from solid straight to gas without passing through the liquid form. Take note of all this. Let's go into properties of matter. But before we go into properties of matter, I wanted to note this. There's a question that usually comes out in chemistry from the boiling and the melting. Now, the heat absorbed during a change of state, either from a solid to a liquid or from liquid to gas, is what we call latent heat. Latent is what is known as latent heat. Don't forget, the heat absorbed during a change of state, either from solid to liquid or from liquid to gas, is known as a latent heat. Now, latent means hidden. Now, let me explain. The reason why this is called a latent heat is because even though heat is continuously supplied or applied to a substance, to a solid when it's about to melt, or to a liquid when it's about to boil, the temperature of the solid, note this, temperature of solid and the liquid at the time of melting. At the time of melting, the temperature of the solid and the liquid at the time of melting is in equilibrium. Now, which is to say that now the temperature of the solid and the temperature of the liquid are at the time of melting, as at the time when the solid is changing into liquid, is at at the time of melting is in equilibrium. That means the temperature is the same. The temperature of the solid is not lesser than that of the liquid. Neither is the temperature of the liquid lesser than that of the solid. Even when heat is constantly supplied to the solid, that is why the heat absorbed as at the time of change of state is known as latent heat. Hidden. It doesn't count. Same thing when a substance is moving from liquid to gas. The temperature of the liquid and the vapors at that time is in equilibrium, is constant. It doesn't change. Note this. Now let's move into properties of matter. Properties of matter. Now, when we talk about properties of matter, we're talking about those things that describe matter. Now, talking about properties are in two categories. We have the physical properties. Physical and chemical properties. Now let's differentiate these two. The physical properties of a substance are those properties that no new substances are formed, or are the substance that can easily be recognized without any new thing applied. Let's say, for example, examples of physical properties. We have color. Once I look at you, I will know that. Once I look at this marker or this cleaner, I will know that's dust. I will know that this thing is green in color. We have color. We have size. We have size. We have shape. etc. Now, the chemical properties are those properties that a new substance is formed that requires a chemical change. Now, we'll talk about physical changes, chemical changes. Physical changes are those changes that occurs in a substance when no new substance are formed, or are those changes that does not require heat or requires less heat. Let's say, for example, melting point is a physical change. Boiling point is a physical change. Change in size, change in color, these are physical changes. And physical changes can as well be corrected by physical means. And for example, of physical means of correcting physical changes, you can have decantation, your separation, and the rest. Now, from here, let's move into elements.